Alright guys, so what we're going to do now for 7.5 is complex fractions. What I need for you to do is, I need you to get a sticky note, because we're going to use that today to make it a little bit easier to approach. So if you don't have a sticky note, just take a sheet of paper and cut it to about this size so we can approach the problems. Alright, so a complex fraction is a quotient with one or both fractions in the numerator or denominator or both. Okay, so these look super intimidating, but we're going to take it by 3 simple steps, and we're going to be able to approach these types of problems. So if I've got 2 plus 1 over 2 over 3 plus 1 over 4, this is called a complex fraction because we have some type of addition and subtraction on the top and some type of addition or subtraction on the bottom. So it creates a big fraction. Or we can have a rational expression, so like 3x squared minus 5x over 6x squared over 2x minus 1 over x. So individually that would be one problem, here would be my other problem, and then together we would divide. Okay, or we could have 3 plus x over 5 minus 2 over x. Now the reason why these are rational expressions is because they contain a variable. Alright, so how to simplify a complex fraction. First thing you do is you simplify the numerator into one fraction. Okay, so the steps that you did for 7.4, you are going to do the exact same things for step number 1. Step number 2, you're going to simplify the denominator into one fraction. Okay, and then the last thing that you do is you divide the two fractions and solve. So remember, when you divide two fractions, you keep, change, flip. Okay, and then you solve it. So, step 1, to simplify the numerator into one fraction, what I want you to do is I want you to take that sticky note and I want you to cover up the denominator. So all we're going to focus on is our numerator or the top, and we're going to simplify that as much as possible. So if I've got 2 over 5 plus 1 over 4, first thing I notice, my denominator is not the same, so I have to find my LCD. And my LCD for 5 and 4 is going to be 20. Okay? So what times 5 will get me to 20? That would be 4. So what I do to the bottom, I have to do to the top. So 4 times 2 is going to be 8 over 20 plus 4 times what gets me to 20? That would be 5. 5 times 1 is 5 over 20. Okay? So if I continue to clean that up, I have the same denominator, and 8 plus 5 is going to give me 13. So I got 13 over 20. And the last thing that I need to check for, is there anything I can do to reduce this? 13 and 20, there's absolutely nothing I can do. So this is all step 1. So we have simplified the numerator into one fraction. Now what we got to do is we got to simplify the denominator. So I want you to take your sticky note. I want you to cover up the numerator, because all we're going to do now is focus on the denominator. So I got 1 over 6 plus 3 over 8. My denominators are not the same, so I have to find my LCD. And my LCD for 6 and 8 is going to be 24. If that's not obvious, then you can go 6, which would be 2 and 3, 8, which is 2 times 4, which breaks down to 2 times 2. So I've got 2, and my max would be to the third, times 3 to the first, so that would be 8 times 3, which would be 24. So that's the 7.3 that we've been working on. So what times 6 will get me to 24? That would be 4. What I do to the bottom, I have to do to the top. So 4 times 1 is 4 over 24, plus 8 times what gets me to 24? That would be 3. 3 times 3 is 9 over 24. So that will be 9 plus 4 is going to be 13 over 24. Alright, so I've simplified the denominator. Alright, so we've done step 1 and step 2, so now we have to do step 3, which is to divide the two fractions and solve. So we've got 13 over 20 over 13 over 24. So we're going to use the keep, change, flip. So we're going to keep the 13 over 20. We're going to change from division to multiplication. And then we're going to flip 24 over 13. Then we're going to just take it like we did in 7.2. So we're going to cross cancels. So the 13s from top to bottom will cancel out, leaving me with 1. And the 20 and the 24, what will go into both of those is 4. So 20 divided by 4 is going to leave me with a 5. And 24 divided by 4 will leave me with a 6. So 1 times 6 is 6. 5 times 1 is 5. I am a-okay with an improper fraction as long as it's reduced down. If you want to change it to 1 1/5, you can, but this is perfectly fine for me. Okay? So it's nothing new. It's just taking an intimidating problem and breaking it down. So let's try another one. So step 1 is we have to simplify my numerator. So first thing I want to do is I want to cover up my denominator with the sticky tack, or sticky note. So I've got 2 over 3 plus 5 over 9. I look at my denominators, they're not the same, so I have to find my LCD. LCD of 3 and 9 is going to be 9. So what times 3 gets me to 9? That would be 3. So I multiply the bottom by 3 and multiply the top by 3. 2 times 3 is 6 over 9. My LCD and my denominator match each other, so I don't have to do anything. So here's 9, here's 5. So 6 plus 5 is going to be 11 over 9. That doesn't reduce anymore, so step 1 is done. Step 2, I take my numerator and I cover it up so I can just focus on my denominator. So at 1 over 4 plus 1 over 12. The 4 and the 12 are not the same, so I have to find my LCD, which for 4 and 12, my LCD is going to be 12. 4 times 3 will get me to 12, so I got to multiply the bottom by 3, and I've got to multiply the top by 3. So 3 times 1 is 3 over 12, plus my denominator and my LCD match each other, so I don't have to do anything with that one, so this would be 1 over 12. Now, 3 plus 1 is going to be 4 over 12, and is that reduced down as much as it possibly can? It is not, so we're going to go 11 over 9, and then this would be 1 over 3, because 4 goes into 12 and 4 goes into 4. So now that it's simplified as much as it possibly can be, now I got to do step 3, so this is the keep, change, flip. I keep the 11 over 9, I change from division to multiplication, and then I flip it to 3 over 1. Now I look to see if I can cross cancel. So 11 and 1, nothing cross cancels there, but the 9 and the 3 definitely will clean up a little bit. So 9 divided by 3 is 3, 3 divided by 3 is 1, so 11 times 1 is 11, 3 times 1 is 3. Alright, so that's the process. We're taking a complex fraction, which is super intimidating, we're cleaning it up by 3 steps, and we're done. So don't be intimidated. You'll have a couple of these on your Chapter 7 test. Now, when there's variables, we're still going to follow the exact same process, so I don't want you to get intimidated by it. So the first thing that I would do before we even read the problem, I see it's a complex fraction, I'm going to cover up my denominator. Now, I'm going to read my numerator. So I've got 2 plus 4 over x. So the first thing I want to do is I want to put a 1 underneath that 2 so that I can make them fractions. So if I look at the 1 and the x, they're not the same, so I have to find my LCD, which for 1 and x, my LCD is just going to be x. So in order for my LCD to match my first denominator, I've got to multiply it, the bottom and the top, by x. So I've got 2x over, and I'm going to put LCD whenever I'm dealing with rational expressions just so it's a little bit cleaner. And then my LCD matches the second one, so I'm just going to go plus 4 over LCD. Okay? So now I can put them together, so I got 2x plus 4 over LCD. And if I clean this up a little bit more, I see that I have a GCF in my numerator. I can pull out a 2, and I'm left with x plus 2 over my LCD, which is just x. Alright, I look at it, there's nothing more that I can do to it, so I'm done with step 1. Step 2, I cover up my numerator and I just focus on my denominator. So I have 5 over 6 plus 5x over 12. I see that my denominators are not the same, so I have to find my least common denominator, which for 6 and 12 would be 12. 6 times what gets me to 12? That would be 2. So I multiply the bottom and the top. So 5 times 2 is 10 over 12 plus my denominator matches my LCD, 5x over 12. So it's essentially I've got 10 plus 5x over 12. Again, I'm trying to see if I can pull anything out. I have a GCF of 5, so I can pull out a 5 and I'm left with 2 plus x over 12. Alright, I look at my denominator, there's nothing more I can clean up, so step 2 is done. Now I get to do step 3. So for step 3, this is where I keep, change, flip. So I keep the 2, x plus 2 over x, change from division to multiplication, and I flip it, so this would be 12 over 5 times 2 plus x. Alright? So now we're going to look to see if we can cross cancel. So anything that's exactly the same we can cancel out. So I got x plus 2 and I got 2 plus x. I can reverse these orders and I can cancel them out because they actually mean the exact same thing. Okay, so those cancel out. The 2 and the 5 doesn't do anything. The x and the 12 don't do anything. So I multiply straight across. So 2 times 12 would be 24. X times 5 is 5x. And that is as far as I can take it. So when there's variables, it takes a little bit more effort, but not much. Okay, let's try another one. Okay, so step 1, we got to deal with the numerator. So I don't even care about the denominator, so I'm going to cover that sucker up. So I've got x plus 1 over y. So underneath this x, I'm going to put a 1 so I can create it to be a fraction, and I see that my denominators are not the same. So I have to find my LCD. So for 1 and y, it's going to be y. So I've got to multiply this first fraction, the bottom by y, therefore the top by y. So I have xy over LCD plus my LCD and my denominator match each other, so I'm just going to go 1 over LCD. When I put those together, I get xy plus 1 over my LCD, which is just y. And there's nothing that I can cancel out, so I'm done with my first step. Okay, I'm going to cover up my numerator so I can just focus on my denominator, and I've got x minus 1 over y. So underneath the x, I'm going to put a 1 so I can create a fraction, and I see that my denominators again are not the same. So I go LCD, 1 and y is going to be y, so I multiply my first by y and y, so I have xy over LCD minus, okay, because it's minus, remember we got to put parentheses around the second numerator, and I can't change anything there, so I'm just going to put 1 over LCD. So when I combine these together, it's going to be xy minus 1 over my LCD, which is y. That's simplified as much as it possibly can be. So now I got to do my step 3, which is keep, change, flip. I keep the first, so xy plus 1 over y. Change from division to multiplication, and I go y over xy minus 1. Okay, I look to cross cancel. These are not the same because one's addition and one is subtraction, but my y's cancel out. So I'm left with xy plus 1 over xy minus 1. And remember, you can't cancel the xy's out because they're attached with addition or subtraction. If they were just by themselves, then you would be able to. Okay? So now let's go a little bit harder, but not much. So what I want us to do first is, we see it's the complex fraction. That looks pretty intimidating. I take my note card, I cover up my denominator. Okay? So now what I'm going to do is I'm going to read the numerator. So I got 1 over a plus 1 plus 2 over b minus 2. So first thing I notice, my LCDs are not the same. I can't factor anything. So since they're not factorable and they don't have anything in common, it's just going to be a plus 1 times b minus 2. Okay, so now I'm going to compare my LCD to my first denominator, and I see what's missing is the b minus 2. What I do to the bottom, I have to do to the top. and since it's 1 times it, it's just going to be that number. So I've got b minus 2 over LCD plus. Now if you want to write that 1 there, then you could do parentheses and 1, but distributing a 1 is going to give it the exact same value. So now the b minus 2, what's missing from that is the a plus 1. What I do to the bottom, I have to do to the top. So I've got 2 times a plus 1 over LCD. Okay? So now I've got to distribute this to 2. So I've got b minus 2 over LCD plus 2a plus 1. No, sorry, plus 2. Woohoo, almost messed that up. Okay, over LCD. When I bring it together, I've got b, my minus 2 and my plus 2 cancel out, so I'm just left with plus 2a over my LCD, which is a plus 1 times b minus 2. Okay, so I've cleaned up my numerator as much as I possibly can, so I'm going to cover it up, and I'm just going to focus on my denominator now. So with my denominator, I see it's a subtraction problem, so I'm going to put my second numerator in parentheses, and I've got 2 over b minus 2 minus 1 over a plus 3. So first thing I want to do is I want to find my LCD. Can't factor either one of those denominators. They don't have anything in common, so it's just going to be b minus 2 times a plus 3. So I'm going to look at my LCD compared to my first denominator, and I see what's missing is the a plus 3. What I do to the bottom, I have to do to the top. So essentially I've got 2 times a plus 3 over LCD minus 1 in parentheses. And I compare my second denominator to my LCD, and I see that I'm missing the b minus 2. So I'm going to multiply that by the b minus 2 over LCD. Okay, so next thing I have to do is I have to distribute the 2, and the 1 times any number is just going to be 1. So I could have just left it as b minus 2. I just wasn't thinking. Alright, so when I distribute that 2, I'm going to be left with 2a plus 6 over LCD. And I got minus, and in parentheses, b minus 2 over LCD. So here, I'm going to have 2a plus 6 minus b minus 2 over my LCD. Now remember, this is just like having an imaginary 1, so we have to distribute that one in. So I'm going to come over here, I'm going to write my original numerator, so b plus 2a over a plus 1 and b minus 2. Okay, when I distribute the negative 1, I'm going to be left with 2a plus 6 minus b minus, plus 2 over my LCD. And what I notice is I can combine some like terms, the 6 and the 2. So when I combine those, I'm going to be left with b plus 2a over a plus 1 times b minus 2 over 2a minus b plus 8. And now, because I can't combine anything else, now I can finally put my LCD, which is b minus 2 times a plus 3. So that's step 2. Now, step 3 is where I have to do my keep, change, flip. So I'm going to do it down here. I'm going to keep the b plus 2a and a plus 1 times b minus 2. I'm going to change from division to multiplication. And I'm going to go b minus 2, because I've got to flip it, times a plus 3 over 2a minus b plus 8. Alright? Now, if I look from top to bottom, I see that I can't cancel anything out because it's attached with addition and subtraction. But if I look from bottom to top, I can see that the b minus 2 will definitely go away for us. So, at the top, I've got b plus 2a times a plus 3 over a plus 1 times 2a minus b plus 8. There's nothing else that cancels out, so I am a-okay with you leaving it right here. I would highly suggest not to FOIL or distribute, because you don't need to. Remember, with rational expressions, as long as it's simplified as much as possible, you can leave it just like this. Okay? So now, this is the last problem that we're going to do, but it looks a little bit more intimidating, but I think it might be a little bit easier than that last problem that we just had. Okay? So, what I want you to do is I want you to cover up your denominator, and let's just focus on the numerator. So underneath the 4, I'm going to put a 1, and I've got 4 over 1 minus 11 over x, so I'm going to put this in parentheses because it's subtraction, minus, put that in parentheses, 3 over x squared. So, first thing I notice, I got 3 things that I'm dealing with, but none of the denominators are the same, so I have to find my LCD. And my LCD for 1x and x squared is just going to be x squared. Okay, so the next thing I got to do is I got to take each individual denominator and I've got to match it with my LCD. So for the first one, I have to multiply it by x squared. What I do to the bottom, I have to do to the top, so I have 4x squared over LCD minus the difference between x squared and x is just x, so I have to multiply by x. So 11x over LCD. Still keep it in parentheses because it's subtraction. And then go minus. Look at my LCD and I look at my denominator and I see that they match each other. So I don't have to do anything except for keep that 3 in parentheses. Okay, so if I clean this up, I've got 4x squared minus 11x minus 3 over LCD. Now, if you have 3 terms, then it could either be an a equals 1, a doesn't equal 1, or a perfect square trinomial. This one is that a does not equal 1. And guess what, guys? I need for you to clean this up. So, this is section 6.3. So I'm going to write it up here. 4x squared minus 11x minus 3. I got to do my a times my c, so 4x squared times negative 3, which would be negative 12x squared. Because I got a negative answer, I have to use subtraction in order to get to my b, which is negative 11x. Factors of 12, 1 and 12, 2 and 6, and 3 and 4. I have to use subtraction, so I'm going to use the 1 and 12, and it has to get me to a negative 11. So I've got 1x minus 12x will get me to a negative 11x. So now what I do is I write this in place of what my b is as 4 terms. So I go 4x squared plus 1x minus 12x minus 3. Then I factor by grouping. I can pull out an x, and I'm left with 4x plus 1. I can pull out a negative 3, and I'm left with 4x plus 1. Those are the exact same. So I've got 4x plus 1. Then I put my leftovers together, x minus 3. And that's as simplified as it possibly can be. So I'm going to go x squared. So nothing new, just incredibly tedious. Okay? Now, I got to do the second part. So what I want you to do is I want you to pause it for just a second, and I want you to see if you can do the second part by yourself. Alright, so I'm going to put this 2, I'm going to put a 1 underneath the 2 to make it a fraction. So I've got 2 over 1 minus 1 over x minus 15 over x squared. I'm going to put parentheses around whatever my numerator after subtraction is. I notice that my denominators are not the same, so I've got to find my LCD. And my LCD of 1x and x squared is going to be x squared. So 1 times x squared what I multiply the bottom by, I have to multiply the top by. So I'm going to be left with 2x squared over LCD minus x and x squared. I got to multiply by x. So I've got 1 times x, so that would be just x over LCD. And these two match each other, so there's nothing I need to do for that one. So I combine them together, and I've got 2x squared minus x minus 15 over LCD. And again, I look at my top and I see that it is 3 terms, so it's either a equals 1, a doesn't equal 1, or perfect square trinomial. This one is definitely an a does not equal 1. So I take the 2x squared minus x minus 15, and I go through the exact same steps up here. So a times c, 2x squared times negative 15 is negative 30x squared. See that it's negative, so it's going to be subtraction to get to a negative 1x. If you need to put that 1 there, you can. Factors of 30, 1 and 30, 2 and 15, 3 and 10, and then 5 and 6. Okay, so I'm going to use the 5 and 6, but the order is going to be super important. So I've got 5x minus 6x, and that will give me a negative 1x, and I have to take this and I have to replace it back in with my b. So I got 2x squared plus 5x minus 6x minus 15. So I'm going to factor by grouping. Okay, when I factor by grouping, I can pull out an x, and I'm left with 2x plus 5. I can pull out a negative 3, and I'm left with a 2x plus 5. So I've got 2x plus 5 times x minus 3. That is as cleaned up as it can be, so I got to put it over my LCD, which is x squared. Alright, so I've cleaned up my top, I've cleaned up my denominator, so now what I have to do is I have to do my KCF, so keep, change, flip. So I'm going to keep my top of 4x plus 1 times x minus 3 over x squared. I'm going to change from division to multiplication, and I'm going to go x squared over 2x plus 5 times x minus 3. I see that these two will cancel out with each other. Also, the x squareds cancel out with each other, and I'm left with 4x plus 1 over 2x plus 5. And that's as much as it can get cleaned up. A common mistake that I've seen before is people try to cancel out the 2 and the 4. But you cannot do that because it's attached by addition. Alright, this is probably about as hard as it gets, just because there's a lot of steps to it. So please make sure that you take your time. Alright, so the last one that we have is a now you try. So I want you to pause it, and I want you to try to do it yourself. Alright, so what I want to do first is I want to cover up my denominator, and I want to put a 1 underneath the numerator of m. So I got m plus 1/2. I notice that my denominator is not the same, so I have to find my LCD, and for 1 and 2 it's just going to be 2. So 1 times 2 will get me to 2. So I've got 2m over my LCD, which is 2, plus my LCD matches my second denominator, so I've got 1 over 2. So this would be 2m plus 1 over 2. And there's nothing else that I can do to clean that up. So now I'm going to look at my denominator. I'm going to cover up my numerator. And all I have is 6m plus 3 over 4m. Okay. I have already the denominator and it's already pushed together, so the only thing that I can do is clean up my numerator. So I've got 6m plus 3. This will be a GCF. What I can pull out is a 3. And when I pull out a 3, I'm left with 2m plus 1 over 4m. So I got 3 times 2m plus 1 over 4m. So that's cleaned up as it can be. So now I have to keep, change, flip. We got 2m plus 1 over 2 times 4m, got to flip it, and then 3 times 2m plus 1. Whatever is exactly the same I can cancel out, so I can cancel those out with cross canceling. If I need to put a 1 there just for placement, you can. Then we got the 4 and the 2. So 2 divided by 2 is 1, 4 divided by 2 is 2. So I'm going to be left with 2m over 3 as my final answer. Hopefully you got that one right. Alright guys, so now what I need for you to do is I need you to do some practice with 7.5 homework. It will take some time, but make sure you show your work. It should be okay. It's nothing new, it's just putting a lot more work together. And I would highly suggest to use a note card. Alright, thank you.